Hello, discrete math fans. Now we're going to talk about conditional statements. When we talk about a logical inference or a deduction, that's when we reason from a hypothesis to a conclusion. What we want to be able to say is that if we know one thing, then we can deduce the truth of something else. And this is how we produce new truths in mathematics. So let's let P and Q be statements. And anytime we have a sentence of the form, if P then Q, then that's going to be denoted symbolically by this expression here with P and then a little arrow, and then Q. P is called the hypothesis, Q is called the conclusion. Okay, as an example, let's look at this statement. If 576 is divisible by 12, then 576 is divisible by 3. So this notation, this P arrow Q, this is going to give us a new connective, just like and or. They're going to join statements to create new statements. So in order for us to define P arrow Q as a statement, what we need to do is specify the truth values for P arrow Q, just like we did for P and Q and for P or Q. So in order for us to create the truth table, what I'd like to do is work through an example. Let's suppose you're bird watching, and every time you observe a bird, you make a note of two things: the type of bird and its color. And before you start, an ornithologist, a bird expert, gives you the following fact about birds. If you see a crow, it will be black. Now, right now, we don't know if this sentence is true or false, but we're going to think about some of the observations we might make. So, in particular, what I want to do is decide under what circumstances would you be able to say that the bird expert spoke falsely? Let's consider some different observations that we might make. All right, so these are some observations that could have happened while we were bird watching. You see a crow and it's black. You see a sparrow and it's black. You see a cardinal and it's red. And you see a crow and it's purple. Those are 4 possible observations you might make while watching birds. Although, I guess I should say that it's pretty unlikely that you would see a purple bird. I guess it could happen. Now, which of these 4 observations would cause you to say that the bird expert led you astray? That is, the bird expert told you something false. Well, now, if observation 1 doesn't do anything to let you believe that the bird expert told you something false, that really confirms that they're right if you see a crow and it's black. What about observations 2 and 3? Well, the bird expert said, if you see a crow, then it's black. But in observations 2 and 3, you're observing a sparrow and you're observing a cardinal, so it doesn't do anything to dissuade you from believing that the bird expert is telling you something true. So after the first 3 observations, you're pretty much convinced that the bird expert does know what he's talking about. So none of those observations lead you to believe that the bird expert told you something untrue. What about if you had observation 4? You observe a crow, but it's purple. If you really saw that, then you would say, now wait a minute, this bird expert doesn't know what he's talking about. So in that 4th case, the hypothesis was true. You saw a crow. The conclusion was false. The bird you saw was purple. So what I can say is that the only combination of circumstances in which you would call a conditional sentence false That happens when the hypothesis is true and the conclusion is false. That's the only time. So based on that, let's create a truth table for P arrow Q. It looks like this. Notice that the only time we end up with a false result is when the hypothesis is true and the conclusion is false. Otherwise, all the other times we get a true result. So we make a definition, and our definition will say that if P and Q are statement variables, then the conditional of Q by P is if P then Q. And actually the most common way that we're going to be saying this is P implies Q. And this is going to be denoted with our arrow notation that we've talked about before. What we haven't said anything until now about is how you say this. We're not going to say P arrow Q, we're going to say P implies Q. It is false only when P is true and Q is false. Otherwise, it is true. And as we've discussed before, we're going to call P the hypothesis. Sometimes that's called the antecedent. And Q is going to be the conclusion, also sometimes called the consequent. I think I'm going to stick with hypothesis and conclusion in this class, but you might see other words for that. Okay, that's all for now.